You've seen train tracks your whole life, but you've probably never asked this one question. Why are they built on rocks instead of something solid? Imagine this. You're standing at a train station. A train rushes past you at full speed. The ground shakes. The sound roars. And for a split second, you look down. Not at the train, but at what's beneath it. Rocks. Thousands of them. Sharp, rough, uneven, stretching endlessly along the tracks. And suddenly a strange question appears. Why? Why are we running some of the most advanced machines on Earth on a loose pile of stones? Why not something solid? Why not concrete? Why not build something stronger, more modern? Because what looks simple is actually one of the smartest engineering decisions ever made. To understand this, you have to think about one thing: weight. A fully loaded train isn't just heavy. It's massive. We're talking about thousands of tons of steel, cargo, and force pressing down on a very narrow strip of track. Now imagine placing all that weight directly onto the ground. The soil wouldn't hold. It would compress, sink, shift, and eventually, the track would warp. And when the track warps, the train derails. So engineers needed a solution, not something rigid, but something smarter, something that could spread pressure, absorb force, and adapt under stress. And that solution was stone. If you look closely at a railway, it's not just rails sitting on the ground. It's a system, a layered structure, steel rails on top, sleepers beneath them, and under everything, a thick bed of crushed stone. This is called ballast, and it does something incredibly important. It takes all that concentrated weight and spreads it out across a much larger area. So instead of crushing the ground, the pressure is distributed, balanced, controlled. But here's where things get really interesting. The tracks aren't actually fixed into the ground. They're not deeply bolted into concrete. They're floating, resting on the stones, held in place by friction and weight, which sounds unstable, but it's the opposite, because this design allows the track to move just a little. Not enough to shift, but enough to absorb vibration. When a train speeds by, the force doesn't snap the system. It gets absorbed, dissipated, softened. Now you might be thinking, okay, stones make sense, but why these stones? Why sharp? Why jagged? Why not smooth rocks? Because smooth rocks would fail instantly. Imagine walking on marbles. Everything slips. Everything moves. That's exactly what would happen under a train. If the stones were round, they would roll. The track would shift, and stability would be gone. So engineers chose crushed stone, usually granite or quartz, broken into sharp, angular pieces. And when these stones are packed together, they don't roll. They lock. Their edges grip into each other, creating a structure that is both rigid and flexible at the same time. But the stones don't just support weight. They solve two more invisible problems: water and plants. When it rains, water has to go somewhere. If tracks were built on concrete, water would pool. If built on dirt, it would turn into mud. Both are dangerous. But stones? They drain instantly. Water flows through the gaps and disappears beneath the surface. No pooling, no erosion, just stability. And then there's vegetation. Plants are stronger than they look. Roots can break concrete, shift soil, destroy foundations. But try growing a plant in sharp, unstable stone. It won't last. The ballast naturally prevents weeds from taking over, so these rocks are doing three jobs at once. They carry weight, they drain water, they stop plants, all silently, all the time. But here's the part almost no one expects. The word ballast didn't come from trains. It came from the ocean. Centuries ago, wooden ships had a problem. When they sailed empty, they were too light, unstable, dangerous in rough water. So sailors filled the bottom of their ships with heavy stones to weigh them down, to stabilize them. Those stones were called ballast. And when those ships arrived at port, they dumped the stones, piles of them, everywhere. Years later, Early railway engineers saw those piles and realized something. Heavy, cheap, perfect for stabilizing tracks. So they used them, and the name stayed. So the next time you see a train rushing past, look down at those sharp gray stones, because they're not just rocks. They're a system designed to carry immense weight, fight nature, and adapt under pressure. A system borrowed from the sea and perfected on land, because sometimes the most advanced technology in the world depends on something incredibly simple.